Welcome to a new lesson. In this lesson, we'll be exploring angle properties in triangles. Let's take a look at our first example. In a diagram, angle MTH is an exterior angle of triangle MAT. Determine the measures of the unknown angle in triangle MAT. Let's first talk about this exterior angle MTH. So we start with M, we go to T, finish at H. So here's your angle. This angle is 155. That's your exterior angle. The next thing, we have a triangle MAT. Notice the vertices, notice the names MAT, MAT. And what we're looking for is the unknown angles that we don't know. So specifically, angle MAT, so we don't know that one, MAT. And we don't know angle TM. Specifically, we're looking for, we could call it angle 1 and angle 2, right there. And now let's find those angles. We know that angle 2 and angle 155, when they combine together, form 180 degrees. Angle 2 plus 155 is equal to 180 degrees. And the reason for this, of course, we have to state why. It is because these angles are supplementary. Because of this, we could solve for this angle 2. Angle 2 is 180 minus 155. So angle 2 is equal to 25 degrees. So here's your first measure. Now what about angle 1? We know that now angle 2, so we can erase angle 2 and put it 25. We know that if we take 40 and add to angle 1 plus 25, we'll get 180. And that's because angles, interior angles in a triangle, add up to 180 degrees. We can write that down. Interior angles in a triangle. Let me just draw the little triangle. Add to 180 degrees. Also, we could call this definition of a triangle. There you go, definition of a triangle. Using this definition of a triangle, we could solve for this angle 1 by taking 180 and subtracting 40 and 25. And we will get angle 1 equivalent to 115 degrees. So on the left-hand side, we have a statement of this table. Make sure you always write statement. And on the right-hand side, we always write, this is our reason for this statement. And here is your answer. It's not just enough for you to write the answer. Angle 2 is equal to 25, and angle 1 is equal to 115. You also have to explain how you got to this stage. Let's take a look at the next example. Determine the relationship between an exterior angle of a triangle and its non-adjacent interior angles. Let's draw a picture. So non-adjacent interior angles and the exterior angle of a triangle. So where is the exterior angle? D, right here, is the exterior. And the non-adjacent interior, well, C is the adjacent part, and it cannot be C. So what we really are interested in is the other angles inside this triangle, A and B. So we have to find some type of relationship between D, angle D, some kind of relationship with A and B. So This is not a typical proof that we're looking for, because usually in a proof we have to prove something is equivalent or different or parallel. But in this case, we don't know what the relationship is. So somehow we have to relate D, A, and B together. So the only thing that links these things together is the angle C. A, B, and C are in a relationship with C, and D has a relationship with C. Therefore, D has to have a relationship with A and B. What type of relationship? Well, that's what we're going to be determining right now. So let's first have a statement, and then we have to have some type of a reason. So let's find this relationship. We know that D, angle D and angle C, when they add up, they have to add up to 180 degrees, because they actually are on the straight line. They're supplementary angles. And now what I'm going to do is I'm going to rearrange this. I'm going to rearrange and solve for D. Angle D is 180 minus angle C. I'm just going to underline this equation. The next relationship is between A, B, and C. I know that if I were to add these angles together, angle A plus angle B plus angle C, I would get 100 degrees, because that's the definition of a triangle. So now I'm going to rearrange A, B, and C so that A plus B is equivalent to 180 minus angle C. And now I'm going to underline it. What's interesting about it that 180 minus angle C and 180 minus angle C is equivalent to angle D and angle A plus B. If they're both equivalent to the same thing, they also have to be equivalent to the same thing too. Therefore, angle D is equivalent to angle A and plus angle B. And that is called transitive property. Remember that if A is equal to B and B is equal to C, then C has to also equal to not B but A. And that's what a transitive property is. Let's take a look at the next example. Determine the measure of angle NMO and angle MNO, as well as QMO. It's a lot of letters. Let's simplify these angles a little bit and call them angle 1, angle 2, and angle 3, and let's put them into our picture. So start with the first angle, which is NMO. So start with N, go to M, and finish at O. So that's angle 1. So here's your angle 1, and we'll just write it as 1. What about M and O? And M and O, so this is M and O, and that's a different angle, and that's 2. And they're different, so I'm going to put 2 arcs instead of 1. There you go. And the third angle, QMO, start with Q, go to M, and finish at O. And let's call it 3. And have a little 3 arcs to illustrate it. Make sure that they are different from each other. So 3 arcs and angle 3. And now we're going to try to find these values. What else you have to see from this picture is that all the other angles that are given, 67, 20, 39, as well as any other clues such as these parallel lines. So this line, MQ, is parallel with NP because they have this arrow. That shows you that they are parallel to each other. Also, you have to be careful so that you don't make any assumptions. I've showed you thus far is that whenever you have parallel lines and you have the Z pattern or a different Z pattern, then you will have interior angles that are equivalent, interior alternate angles. But just because you see a Z pattern like this one, it doesn't mean that all of these lines will be parallel, question mark. I see this Z pattern right there. But as you could see, if you extend these two lines together, they will actually meet at one point. So these two lines are not parallel. Don't make that assumption that they are. Another assumption is that looking at an angle and trying to guess what this angle is just by looking at it. Well, just by looking at it, this angle right here looks to me like 90 degrees. But you can't make that assumption unless it actually says on the picture that it's 90 degrees by having the square that illustrates a 90-degree angle. Then you could say it's 90 degrees, but because it's not on a picture, it's not 90 degrees. So don't make that assumption. The next thing handy is to have a formula sheet or a different way to remember all the rules that you've learned about parallel lines and straight lines and triangles. Well, we know that if we have a triangle, the sum of the interior angles is 180 degrees, so that's good to know. We also know if we have parallel lines, we have interior alternative angles that are equal. Also, if you have parallel lines, we have this F pattern. We also know that, where's the F pattern? The F pattern tells us that these angles are corresponding, they're equivalent. We also know that exterior alternative angles also are equivalent. And these are the angles that I'm referring to if and only we have parallel lines. So it's difficult to see initially what we do in this question. How do we tackle this problem? Notice that we have this triangle right here, so maybe we could use one of these triangles laws. Well, the problem with triangles is that we have to have two sides, not two sides but two angles. We have only one, so that can't be done. We can't use it to solve it. So what I will attempt is I will show you that there is a Z formed right here with the two parallel lines. This tells us that the 67 and this entire angle right here is interior alternate. These two angles equal. So 67 is equal to angle 2 plus angle 20. Notice that when we're labeling, we don't know the unknown. We write the little angle sign. Now we're going to solve for angle 2 by subtracting. 67 minus 20 is equal to angle 2. And that is equal to 47. So angle 2 is 47. One thing that we did forget is that we have to have an explanation for it wherever we write a statement. And of course this explanation is interior alternate angles. Interior alternate angles. The next stage, since we found 47 for angle 2, is of course you raise the angle 2 and put in 47. Now we can look back at the triangle and say, okay, now we have a triangle with two angles and one missing angle. We can use the definition of a triangle to find that missing angle. So therefore angle 1 plus angle 47 plus angle 39 is equivalent to 180 degrees, and that's because of definition of a triangle. And now we could solve for this angle 1. (94 degrees). So we found out the first angle and second angle. Now what about the third? And I'm going to erase some stuff, and so we have more space. Of course, don't forget that since we found this angle 1 on the picture, replace angle 1 with the value of 94. The last thing we'll have to look is that this is a straight line. And these three angles right here add up to 180 and make a straight line. So we know that 67 plus 94 plus angle 3 is equal to 180. And that's called supplementary. Now we could solve for angle 3 by going 180 minus 67 minus 94. Therefore, angle 3 is equal to 19 degrees. And here are three angles. On the end of it all, make sure that you put specific values for the angles that we started with. Instead of angle 1, 2, 3, make sure you put that NMO is 94 degrees. Angle MNO is equivalent to 47 degrees. And the last angle QMO, which is the third angle, is 19 degrees.